Alright, let's move on to the next topic. There are several functions to determine the dimension of the vector or matrix. So when you're writing a code, you often don't know the size of the array. Okay? Then the size and the numeral are most frequently used the function to check the size of your variable. Okay? Size is the function, and there are two outputs. The first one is the row, the number of the row, and second one is the number of column. Of course, there are many different format, output format or the input format, but this is the usual form. Okay. So the output values are, so basically size, function produces two output. First one is the number of rows, second one is the number of column. So those value is assigned to this variable, R and C. Okay, you can, put any, variable name here. Okay, the values are inside of those variable. Okay, so if you see this one, so we will learn about this, the function format. But basically, you're going to use the bracket here, and then place the variable here to store the output value from your function. Okay. Besides, it's giving you it's like a row, number of row or number of column. So numeral is return the total number of element in a vector or matrix. Okay, let's see this example. M1 is the 2 by 3 matrix, right? If you put you apply this size function, R1 become a 2, RC1 become a 3, right? So what about the numeral? Numeral is the number of element is 6. Okay. All right. In the previous slide, we already learned how to joining the two vectors in the same direction, right? So we can make a matrix joining the two vectors in other dimension. For instance, here, you can joining the row vector in a vertical direction. You can make a matrix, right? If you're joining the column vector in a horizontal direction, you will become a matrix. You can make a matrix, right? You can also joining the matrix as well. For instance, here, okay, I write down M1 is the, maybe like this. M2 is the, let's do them. When you define this one, we need to write a script like this, right? Okay. So what about this one? This one is the 1, 2, 3, 4, 1, 2, 3, 4. Okay, joining in the row direction. What if this one? Okay, this one is 1, 2, 3, 4, 1, 2, 3, 4. It's a joining the column direction, right? It's exactly same the way of the concatenation. Okay, good. All right, empty vector. Empty vector is a vector with no element. Okay, this one is used for deleting the element. Okay, let's take a look at this vector. V1 is a 2 to 6, right? if you're pointing out and element, and then use this empty vector, then delete the pointed element. Okay, then actually so your dimension of the vector is changed. Okay, you can delete any element. For instance, here you can pointing out the third element and then put the empty vector. You can delete this element, and then the value in the place in the following dimension is shifted into the top dimension. Okay, so V1 become a 2, 3, 5. What about the matrix? This one is a vector case. But what about the matrix? In the matrix, you cannot remove the single element or submatrix. For instance, I would say let's remove the one element. This become a matrix? No, right? So think about if there's no value, how these arrays become a matrix, right? So if you want to delete some kind of element in a matrix, you need to delete the whole row, entire row or entire column, or entire multiple column or entire multiple row. For instance, here, this one is pointing the second row, right? You put the empty vector, you can delete this one. So that's why your matrix become like this. Okay. Again, you cannot delete the individual element, or you cannot delete the submatrix. For instance, here, you cannot delete this one. Okay. This become a matrix or the vector, right? Okay. You cannot delete the element or single element or it's a submatrix. Or this submatrix is fine because this one is this entire column is a multiple entire column. So it become if you delete this one, it become like this. Scalar operation. We'll learn about the several operator or operation later. Okay. We first talk about how to use the operator when the scalar is involved. For instance, here, what about this one? Okay. The left-hand side is a vector. We'll learn about this one, right? In this case, this one is a scalar, right? This one is a scalar. Here's your operator, right? Basically, I'll say this one is your operator. But in this case, this one is a vector, right? Vector and scalar, right? This numeric operation is performed every single elements on the vector or the matrix. For instance, here become a 3 multiply 4 is placed in the first location of the vector 1. 0 multiply 3 is the second location. 11 multiply 3 is the third location. That's why you will get this one. I mean, actually, this scalar operation is applied for all the numeric operator. Numeric operator is a plus, minus, divider, and multiplication. Okay. If you do this one, so this one is a 0 vector. Okay. So plus 5, that is 5, 5, 5. Okay. In the module 1, okay, not this one. Okay. We learn about this one. This star is a operator. Okay. Okay, let's say operator is a multiplication. 3 multiplication 4 is a 12, right? We learn about in this operation is a module 1. Okay, but this slide is talks about the vector and scalar. But in this operator is just a numeric operator. Okay? MATLAB made this operation is like this. How? This scalar and numeric operation is conducted every single element in the vector or the matrix. There's a rule that MATLAB made. Okay? Makes sense? Good. Array operation on the matrix A and B. Okay? In this case, we assume that A and B are the same size. Okay? It works if the size are different, but let's assume that A and B are the same size. Okay? How the MATLAB is define this operation? When this one is a numeric operator, right? This is a numeric operator. And then A and B are matrix, right? Matrix and then matrix. This one is element-wise operation. Element-wise operation means here 2, 3, 1, 2. This one is A. 1, 1, 1, 1. B is if A plus B equal to element-wise, this operation between the value at the same location. 2, 1, 3, 3, 1, 4, 1, 1, 2, 2, 1 is the 3. Okay, that is element-wise operation. Minus is also same. Okay, if you want to do this element-wise operation for multiplication or division, you need to put dot, okay, in front of your multiplication, divider, or this exponentiation. Okay, but at this point, this is not important, but put the dot in front of the multiplication and then divider. Okay. Okay, here multiplication and then dot multiplication is never be the same. Okay, there are totally different operator. Okay, when this matrix, two matrices are involved. Okay, so minus and plus and minus is a totally different operator. Similarly, multiplication and dot multiplications are totally different. Okay, dot multiplication is element-wise multiplication. Dot division is element-wise division. Okay, so again, matrix multiplication is not an array operation. Okay, this one is not equal to this one. Okay, we will show the example. Okay, dot multiplication, dot division, and plus and minus when the two same size matrix is involved, that is element-wise operation. Okay, let's see this. M1 is this matrix constructed from this script. M2 is this script. SV is a scalar, just a single 3. Okay, if you plus M1 plus M2, that become this matrix Y plus 1 plus 1 is a 2, 6 plus 2 is a 8, 9 plus 1 is a 10, like this. Okay, element y is a summation. Okay, this one is the same. Element y is a subtraction. 1 minus 1 is a 0, 2 minus 1 is 1, 5 minus 2 is a 3, like this. Okay, and dot multiplication is element y is a multiplication. 1 multiply 1 is a 1, 2 multiply 1 is 2, 5 multiply 5 times 2 is a 10, 8 times 1 is 8, like this. Okay? This one is here. Division is also similar way. Okay? Again, this one is a dot multiplication, dot division. Okay? What about the scalar operation? Okay? We learn about the scalar operation here. Matrix. In the previous example, we are dealing with a vector, but here is a matrix and then scalar, meaning that we are adding this scalar every single element in the M1 matrix. So M1 matrix plus 3, 4, 5, 6, like this. Okay. What about the multiplication? Multiplication is the same. Multiply the 3 to the every element. Okay. So here's 3, 9, 3, come on. 9 times 3 is a 27. Okay. Makes sense? Element wise operation. Okay. Okay, good. Okay, now we are talking about the matrix multiplication, matrix operation. Okay. Matrix multiplication is just a single multiplication symbol, no dot. Okay. Okay. Matrix multiplication is a multiplication you learn in the linear algebra course. Okay. The operator, this operator without dot is a matrix multiplication between the A and B. Okay. But here, if the matrix A is a dimension is m by n, B is m by something, okay, this inner dimension should be matched to conduct this matrix operation. Okay, the outcome become a outer dimension. For instance, A, I'll say m by n, B is the m by p. Okay, this inner dimension is a match. So A multiply B become the dimension of A multiply B is m by p. Okay, this is something that we already learned in linear algebra course. Okay, so to remind your memory, so here this is a matrix times a vector. Okay. So these are the vector, this is a matrix. So we multiply the matrix times a vector. So the operation is, you can element-wise the multiplication of the row vector and then column vector and then summation, like this. Multiply x1 times a11 plus x2 times a12 plus up to the xn times a1 and that's the b1. Okay, you can compute the b2 and b1 bm in the similar way. This is the matrix multiplication. Okay, does it make sense? Okay. How to write a code in the MATLAB? So see this, M1 is the 3 by 3 matrix. Okay. V1 is a column vector because I transpose here. Okay. What happens if I multiply M1 and V1? But first, can you multiply M1 and V1? Yes, why? M1 is the 3 by 3, B1 is 3 by 1. So inner dimensions are matched, right? So output is the 3 by 1, right? So what about the matrix times the matrix? So this one is it's the same, but there's a multiple column. Okay, so basically this one is a matrix, this one is a multiple column matrix. Okay, so if you multiply A and B, your output matrix is the A, B1, A times the V1 column vector, A, B2, like this. This one is the P dimension, right? Okay. Here's the example. Okay. What is M1 times M2? That is M3. How do we compute that? You do this operation and then find the 5. And then this operation and you compute the 4, right? And then this one. Okay. This one. And you compute the 11. And this one. And you will see this one. Okay. But this slide showed how to implement this matrix multiplication using your MATLAB code. Okay, so there's no just a multiplication. Okay. Here's another example. Okay. I like this example because you will see this example in your tutorial and homework, even in your maybe the quiz. Okay. So how to write a script to compute the A, B, C, D using the M1 and V1. Okay. M1 and V1 are already provided. Okay. How to compute the A value? This one is the V1 transpose, right? So this one is a matrix multiplication. So V1 transpose matrix multiplication M1, right? What about this one? This one is the transpose M1 multiply V1, right? This one is there's no this vector, but this vector is here, right? So this become a M1 first column transpose multiply V1. So by the way, there's no such kind of the syntax, okay? There's no this syntax, okay? This transpose is always at the end of your variable. Okay? Okay. Like this, okay? So positive. All right. What about the D? D is this value, right? So V1, V1, 1, 2, and transpose multiply M1. But again, this is your choice to put the bracket here or not. Okay. But by the way, in this case, you should not write a script like this. Okay, this is wrong, right? This produces this one. That's why so we can write this script without the square bracket. But you should not write a script like this. Okay? This is the wrong syntax. Okay? Wrong. This one is correct. Okay? Okay, good. We'll learn how to store the single character, right? Do you remember character like this? This one is a single character. Okay. Now we are going to talk about how to store the sequence of the characters. For instance, how to store this sequence. Hello and how are you? Okay. We use the vector. Okay. That is called the character vector. Okay. The syntax and its uses are exactly the same as the numeric vector. Okay. Remember that in the matrix stored the same types of the value, right? In the previous example, we are dealing with the numeric value, but in this case, we are stored the characters into the vectors or the matrix. Okay. Here's the character vector. It's a MATLAB. What is the dimension? What is the character? What is the number of characters? It's 6, right? This one is 1 by 6, a vector, right? Each element inside M, A, T, L, A, B, right? 6 character. So that's why if you this is a size function, the number of elements is a 6, right? But again, the syntax of the using this vector is exactly same the way of we are accessing the numeric value. So if you see that if you put the 3, the third value of this matrix is this one is 1, 2, 3, right? T, right? So what about this one is reading the third value, right? And then assigned to the character 3, T. 1, 2, 3, mat, right? We can also concatenating the character vector. So in this case, the character vector is a MATLAB, right? We can concatenate this is fun into the MATLAB. So you will have MATLAB is fun. Okay? Does it make sense? Again, I will highlight that the way of the manipulating the character vectors are the same with one used in the numeric vector. Okay? Okay. Yeah, this is a bit more challenging. Okay? I would explain this format first. Okay? I mentioned earlier in the previous lecture 0, the overview of how to study the course material video. This one is a script window, right? And these are the command window. Okay? This format explains that you first run this script, then this variable are loaded and then present in the workspace, right? And then you can access those variable from this command window. So this line is your command. It's like your script and enter. This value is printed out into your command window. In the module 1, we learn about the typecasting, right? Logical type value become a double type value. Double type value also change it to the logical type. Okay. Here, the question is, what if we convert the character type to the numeric type? Again, what happens if we convert the character type to the numeric type? Okay. All the characters are mapped to the equivalent numeric value. Okay? For instance, A is the equivalent numeric value is 97. Okay? So if you're typecasting, if you try to change this character to the double is a numeric value, that become a 97. Okay? What about the double B? That is 98. So basically, is the corresponding the numeric value of the alphabet are continuously increased. So that's why the numeric value, equivalent numeric value of the C is a 99. D is the 100. That's why you will see the 100. Okay? Again, it's like a character is a map to the numeric value. Numeric value also map to the character. So here, if you typecasting, changing the types of the numeric value to the character, it become a because the 97 indicating this character. 98 become a B. Okay. So here, C is the character vector, right? So this one is a 1/2 vector. So it's stored like this. Okay. So if you change this character to the double, what we get, that is 97, 99. It is a 1/2 vector as well. Okay, so here this numeric vector is converted to the character. It become a character vector. Okay, does it make sense? Okay, it's like a common mistake is like this one. What about this one? I know you're confused, but what is this one? This one is something else, but not 97. Okay, why? So this one is a 9 character. So this one is also 1/2 vector. So first element is a 9. It's a 7, right? So there is corresponding value of this one. Okay, you can type this way, you will see the value. Okay, but my point is this is not the 9. Okay, makes sense? These are the vector. This is not a value. Okay. Next, what about this one? What about this one? Okay. So to understand this output of this script is, first, what is the plus? Plus is a numeric operator. Okay, plus is a numeric operator, meaning that you need to have two numeric value. One is a numeric, but AB is not a numeric. This one is a character vector, right? So MATLAB implicitly converted this character vector to the numeric value. Numeric factor, right? Not the numeric value. So this one become implicitly this one become 97, B is a 98. This plus 1 is D here. Does it make sense? Okay. Again, plus or the numeric operator need the numeric value in between this operator. So this should be numeric value. This should be numeric value. Okay? But in this case, 1 is the numeric value, right? Maybe plus or the minus. The CD is not a numeric value. It's a character vector, right? This one is implicitly converting to the numeric value. What is the numeric value of the C? Is that this one is a vector, right? So 1 by 2 vectors. So implicitly converting to the numeric vector, that is a C is the 99, right? 99. D is the 100, right? Minus 1 is the 98, 99. Okay. So this one is, just, what is this one? 98, 99. Again, there's a unique numeric value of each character. So 98 indicating B, right? 97 is A, 98 is a B, 99 is D, C. That's why you will get this one. Okay? Does it make sense? This conversion is very useful for character manipulation later. But in this slide, you just understand how it works. Okay? You can just explain me, or you can just explain yourself that why this become this one, why this become this one. Okay. All right. And remember the last term. So students, found the difficulty in this understanding of the 3D matrix. This 3D matrix is just having another dimension in the depth dimension. So that's it. So you can just think of this 3D matrix as stacking the multiple 2D matrices in a depth direction. Okay. You have a matrix here. This is the row direction. This is the column direction. Depth direction is that one. Okay. You're stacking the 2D matrix. That's it. That's the 3D matrix. So these are the depth dimension. 3, 4 is a 2 depths, meaning that there is a 2 2D matrix is stacking in the depth direction. Okay. So this one is just initialize, and then you make the one matrix, mat1, and then you make the another matrix, mat2, and then you place this mat1 in the first layer, and then place in the mat2 in the second layer. If you visualize as a mat3D, it looks like this one. Okay. The first layer and the second layer. Okay. First and the second layer. Okay. You're going to read all value in the column and row. The first layer. Column and row in the second layer. That's why this become a 2D matrix. Okay. Does it make sense? Okay. Let's look further. How to accessing those value. Okay. That's exactly the same with the one they used in the 2D matrix. Okay. Here, the meaning of this one is okay. First row, third column, and then first layer, that is a 3. Okay. What about this one? first column, first row, first column, and then second layer, that is 13. Okay. What about this one? First and second row, first and second column at first layer. 2, 1, 2, 5, 6. This one. So basically this one is a sub-index, a subscript. Okay? 1, 1, 1, 1, 2, 1, 1, 2, 1, 3, 1. Basically, in a third dimension is all 1 because it's a first layer. This one is a second layer, that's why I put the 2. Okay? Makes sense? So basically in this lecture, you just know how to define the 3D matrix, then how to access and assign the element. That's it. You will see how to utilize those matrices for solving the actual problem later. Okay? Good. Okay. This is a final topic for Module 2. We learn accessing and referring to the matrix using the subscript, which is the row and column index. Okay? But here, we can access the matrix using the single number to do this process. That's the linear indexing. Okay? Basically, let's take a look at this one. This one is a 3x4 matrix. But MATLAB stored this matrix as just a single sequence of the number with the linear indexing order. Linear indexing order is the top and bottom, and then left and right. So here, the order is just a column by column from top and bottom. So this one is a 3x4 matrix. So the way of the store this value is this one, like this. Okay, this one is a linear indexing. So if you flatten this, this matrix is a 3, 4, 5, 2, 2, 7. Because this one is the order of the linear indexing. Okay. So if we can accessing the value using just a single number, that is a linear indexing order, linear index, not indexing order. So using the linear index. Okay. So here, okay, if you try to access this number, if you're using the subscript index, you're using this one. So basically it's M1. You need to write like this, or you can just simply write this one. Okay. So let's take a look at the example. Okay. So here M1 is this one is M1, MAD1. Okay. What about the second row and the first column? This one, 3, right? What about the second? That is a linear indexing. Linear indexing. Okay. Second one is here, right? Okay. What about the third row and the first column? That is the 9, right? You can access those values using the linear indexing. It's 12. What about this one? This one is a linear index. This one is multiple linear index. 3, 4, 5. So 3, 4, 5. So you're going to read the 4, 5, 2. Okay. All right. Here's the question. Okay, what is this one? So remember that it's a colon indicate all value, right? So basically this one is a reader all value. Okay. If you run this, you will see like this. Okay. Linear is like you're flattening this matrix using the linear indexing order. Okay. Similar to the 3D matrix slide, you just know how to read a value using the linear index. That's enough. So we will learn how to utilize this linear indexing in the later topic. Okay. Okay. I frequently use the reshape in the tutorial and the homework assignments. Reshape is just a reshape your vector or matrix. Okay. A is your matrix, and then SC is the size. Okay. When you use these functions, the number of elements of the A must be the same with the one from the B. Okay. For instance, here, your element is a 12 from 3 to 14, like this. And then you can reshaping this row vector to the matrix to 6. The question is how to place this value to the 2 by 6 matrix in order of the based on the linear index. So linear index is like this, right? So top and bottom, column by column, right? Like this, right? You place the 3, 4 like this, right? Okay. Okay. Similarly, you can reshaping this row vector to the 3 by 4. The way of placing this value is the same: 3, 4, 5, and 6, 7, 8, 9, 10, 11, right? Mat 2 is the same as the column first, and then move on to the next column. If you are using the MATLAB, you will see many error messages. Debugging, which is fixing this error, is a very time-consuming process. Saving those time is the key of becoming a good programmer. In MATLAB, there's 3 types of the error: syntax error, runtime error, so logical error. Syntax error is just a simple mistake in the use of the MATLAB language. You are using the wrong variable name or the wrong syntax like assignment structure. So for instance, here it's a wrong assignment statement, right? But in this case, it's a wrong variable name. Okay? But in this case, the MATLAB itself will flag a syntax error in your editor. Okay? You will see the warning message in these types of the syntax error. Okay? But MATLAB Grader doesn't have any function to catch those syntax error. That's why I recommend using the MATLAB, the script window, so that you can speed up your programming. Okay. Another error is the runtime error. Your syntax is fine. Okay, but the error can be found once we run your script. For instance, reading the value outside of your input vector, your variable. Okay. For instance, there's no 4, the force value, so you're trying to reading the value. In that case, that is a runtime error. But here, the syntax is fine, right? But good thing is, all the syntax errors, a runtime error, is produce this error message from your MATLAB. Okay. Okay. Worst error is a logical error. Okay. They're undetected by the MATLAB. Okay. For instance, I highly emphasize the dot multiplication and the multiplication are different. Okay, so let's assume that you're trying to do the matrix multiplication, but by mistake you put the dot in front of the multiplications operator. Then this errors is not detected. Unless you check the individual line and individual value, you cannot fix this error. You cannot, right? So in programming, it is important to avoid these three types of error, especially for this logical error. Before closing this lecture, so we're going to solve the two example. The first one is what script is occurred the runtime or syntax error. What about this one? 10 by 10, 10 by 10, accessing the first and the second row, and then fifth and 10th column. Can we take this out? No, right? We cannot delete the sub-matrix, right? This error. What about this one? This one is also same, right? First row and then fifth column. No, there's a single value. Can we take out the single value? No, right? Okay. What about this one? By 10, first row. Okay. You're pointing out the two location, but you only assign the single value. It works? Yes. Why? There's you can assign the only one scalar value without the matching the dimension, right? This is 3 is a place here. Okay. What about this one? Of course, it's no error, right? You define the mat1, and then you override the mat1 with this matrix, right? This is not a modifying value. This is like overriding. Okay, that's why there's no error. So answer is first one. Okay. Last problem. So I already mentioned that I like these types of the problem. Okay. So write a code to compute the value 1, value 2 is a mat1 using the ABRC. AB is a matrix, R is a row vector, C is a column vector. Okay. So how to compute the value 1? The simple way is C1 R1 plus C2 R2 plus C3 R3, right? Or you can like this, write this. Okay. This one is the matrix multiplication. So to be precisely, this one is a vector multiplication, right? Multiply C1, C2, C3, right? Okay. This one is a matrix multiplication. I would say the vector is also matrix, right? So like this. Okay. How about this one? It looks like this one is element-wise multiplication, right? So this one, but this one is the row vector, right? So we need to make this one as a row vector. So R dot multiplication C transpose. Okay. And the last one is you try to multiply the R1, R2, R3, R4 in each column. Okay, so R1 is the R1. So it's kind of the, we are going to make some kind of the new matrix in the Duda. Matrix is a element wise is a multiplication. So what about this matrix? R1, R2, R3, R4, 1, R2, R3, R4, like that. And we multiply the element wise multiplication. We'll get this one. That's all. Sorry for the long lecture. See you next lecture. Bye.